for those who stayed. I appreciate that. So this will be a second talk related to our security project, which investigated security of the digital satellite TV ecosystem. This time it's going to be a little bit more technical, and it's going to be presenting to some other issues. And we're going to repeat stuff I said about security declarations. So let me say something about the presentation goal. So we want to continue the presentation and reveal some other information that we discovered when it comes to researching digital satellite TV set-top boxes. We would like to educate you about security risks associated with licensing technology, ecosystems such as digital satellite TV, some insecurely implemented proprietary hardware components, as well as so again, a disclaimer, this stuff is even more sensitive than the previous one. So I want to emphasize once again that this presentation, all information is provided for educational purposes only. We do not encourage or promote. Prohibit. So why bother about content security? So digital satellite TV is these days primarily about content security because premium television networks broadcast and deliver their premium content by the means of satellite TV. And pay TV piracy remains a major concern for many channels and operators. And the reason is because it leads to financial losses in North American pay TV. The security of premium content. So content is not delivered to set-top boxes in clear text. It's encrypted, it's broadcasted in encrypted form. The proper flag and the transport stream packet network. Usually, set-top boxes use dedicated security chipsets for decryption, for speed, and for security. And when it comes to the key components, subscriber sponsor, smart card holds information about the subscriber's access rights to different programming, different channels, and this given content. So when it comes to the control words, which are at the key of the whole thing here when it comes to the security of digital satellite TV system, as I said, 64-bit secret keys used to scramble encrypted MPEG streams. They are used for audio. HBO uses different keys than, for example, Fox. And they are generated automatically by the content provider. They are changed every 10 seconds. Yeah, there are different keys, odd and even keys, and the keys are broadcasted to the client devices in encrypted form, and usually some kind of asymmetric crypto is used for that purpose, and the keys are carried in entitlement control messages, or they contain the and the message format is specific to a different conditional access system vendor. So the PID of MPG stream carrying given ACM messages can be found by some CA descriptor, which is usually broadcasted as part of elementary streams associated with the system that protects the content in a satellite set-top box environment. So it simply makes sure that certain criteria are fulfilled before access to the content, to the scrambled content, is granted to a given user. So this is the subscriber smart card, which holds information about subscribers' access to a given programming, and it holds information to what programming packages or video movies, which means paying subscribers can decrypt encrypted programming. So, and this is the set-top box device that asks smart card, give me the control word key for this programming, yeah? And the smart card is going to release the control word key only if a given user is entitled to watch a given programming. So this is basically this architecture. We got this, again, the scrambled MPG stream, and we got, as part of the scrambled MPG stream, we got and smart card is able to decrypt those keys, but the keys which are used to scramble the content are only released by the smart card if the user is allowed to view a given content. So, and of course, when it comes to this model, there are some threats. So the primary threat comes from the fact that all the premium content is encrypted and broadcasted to all subscribers, and there is only one ROC subscriber in your digital satellite TV network. That subscriber can, for example, subscribe to all premium channels and then can start releasing the crypto keys to the scrambled MPG streams. So, and this is why the digital satellite TV industry came up with some other solution, which is called the conditional access system with chipset pairing. And this solution simply tries to tie control words with means that control words are different for a given device and for a given chipset. So this link is applied between a smart card and a client device. So the illegal content redistribution is prevented because you cannot share the keys which are different for every subscriber. Yeah, every smart card releases different keys to a given set-top box because there is pairing, set-top box and the smart card. Oh, and then here we got those. The pairing is marked with this box, and this is the pairing function. And what the pairing does, it simply uniquely ties a set-top box device and a smart card. And the goal is to make sure that the control word keys are not the same for every subscriber. So when it comes to the pairing function, actually not much is known about it when it comes to different documents. Basically, this is a cryptographically function. It ties a set-top box device and the subscriber smart card. Usually it has this form. So the actual tying is accomplished with the use of some encryption algorithm. And what's used is, in this pairing function, one of the key terms is the control words pairing key. This is actually the key which is unique to each subscriber. And this is the key that makes the pairing function unique for each pair by a digital satellite TV operator at the time of activating a given user's subscription. At the time of activating the subscription, this key is sent to the set-top box device and to the smart card. And usually, for the security purposes, this key is unique to a given DVB chipset. So Conax is one of the leading providers of the conditional access system with chipset pairing. Their solutions in software and hardware, and because of the chipset pairing functionality, they need to have partnership with different DVB chipset vendors in order to be able to properly implement the chipset pairing functionality. And these are some of the vendors like Microelectronics, Broadcom, Renesas Technologies, etc. So because Conax wants to make sure that so Conax runs mandatory comprehensive evaluation of all the chipsets that they are supposed to run their conditional access system with chipset pairing. This is done at different laboratories around the world. So those chipsets are then later issued some kind of scoring, and this scoring is certified in writing by the Conax Chief Security Officer. More information can be found on the Conax website, but what I want to show you is that that's the case of Notion company. Okay, so this is going to be about DVB chipsets. So I gave you some introduction to the conditional access system and how the security of content works in the digital satellite TV world. So DVB chipsets actually implement the core functionality which is related to the handling of MPG transport stream and different audio-video data. So they do the filtering, they do the descrambling, they can do audio and video decoding, graphic display. Implemented a system on chips with different dedicated cores inside. So this is one of the implementations of those chipsets. This is the STI7100 single chips, high definition set-top box decoder. This is actually the architecture of the chip. You can see how many components there are. Yeah, so it's pretty complex system, but that's a chip used in set-top boxes for running code, but also for MPG handling and the scrambling. This is the other chipset we work another generation model of the single chip high definition STB decoder, a little bit different architecture, but still a complex system. So we worked with these specific devices, which were also showed during the previous presentation. And these were the ADB set-top boxes. All of them were running upon the ST Microelectronics DVB chipsets. So we found out that these were two generations of these chipsets, generation 1 and generation 2. Well, when it comes to breaking DVB chipsets, so we actually didn't plan this, but at some point of time when we worked with the set-top boxes, we just took the challenge and decided to see if something could be done with respect to the security of content by the malware code. And so the security challenges regarding the breaking DVB chipsets are related primarily to the fact that not much is known with respect to how they work. Not much is known with respect to how the reverse engineer, you just got a piece of silicon, yeah? So how to just start working with this. So many undocumented interfaces, unknown implementation of the cryptographic algorithms and keys. So lots of unknown stuff. So it's pretty challenging thing. So how come? We were able to break a couple of chips. So it definitely took the majority of the 1.5-year time we spent on this project. So this was together and glue together many pieces of information, and we called them clues. And by doing so, it was possible for us not only to discover how certain chipsets work, but we are also able to find security vulnerabilities in them. And of course, we built a couple of tools because, in our work, tools are very important because without the tools, we wouldn't probably be able to finish most of our projects. So some of the common approaches when it comes to working with different implementation. Yeah, so we took some information from data briefs available on the st.com website, and they did contain some generic information about the chip architecture, about some subsystems, some components, and what kind of cores were inside and for what purpose they were used. But actually, there wasn't much. Yeah, so, but something is better than nothing. Yeah, so it still was something worthy for us. first engineer some device drivers. We had full access to the set-top boxes. So this is why this is the second talk. Yeah, it's building on the previous talk. We had full access to set-top boxes, to the Linux OSs, to device drivers. We started to statically analyze binaries available on these systems. What we wanted to find out? We wanted to find out device drivers that handled control words in some way. Yeah. So we inspected the libraries, we checked different symbols, and we find some clues, some information. The security keys in MPG describing. So we had GSEC-HAL device driver, SCTKey DMA device driver. They are for different chips, and because the different drivers for different chips, because the chips are different. So that wasn't enough, because knowing which device driver is responsible for something is just maybe doesn't lead to a lot of clues. So we wanted to find out which function was actually responsible for uploading the key to the runtime analysis engine. We implemented on a set-top box, in a set-top box environment. We used our smart card I/O instrumentation functionality, and we simply sniffed for different ECM messages sent to the card. We watched for the responses returned by the card, and one of these those responses were embedding here the encrypted control words, yeah, because we were working with the chipset. The actual API dealing with the control words, we simply started to do IOCTL tracing, and we found out that there were some IOCTLs which were taking the same arguments as returned by the smart card. So by doing this, we simply could correlate this data, and we could find out which API was handling the key decryption and key loading to the chip. So some other very important thing. Although we work only with we worked primarily with the platform N, digital satellite, which is called TNK. And that's a service along the major digital satellite TV provider. It provides different set-top boxes, and it also has Connex cards. But what's interesting here with respect to the TNK digital satellite TV, the